Hello everyone, myself Dr. Ranjith Kumar Gatla. I am working as an associate professor in Department of Electrical and Electronic Engineering, Institute of Aeronautical Engineering. Today, in this session, we are going to discuss one more topic from the inverters, and that too from the three-phase inverters in module 5, which is the three-phase inverter in 120-degree conduction mode. In the previous class, we have already discussed about the three-phase inverter in 180-degree mode of conduction or 180-degree conduction mode. And we have also discussed what is mean by these 120 degrees conduction mode or 180 degrees conduction mode, which means every thyristor in a inverter will conduct for a duration of 180, then that is a 180 degree conduction mode, and if it conduct for 120 degrees, then it is a 120 degree mode of conduction mode, right? And of course there are some differences are there between 180 degree conduction mode and 120 degree conduction mode. Okay, so especially in 120 degrees mode of conduction, each thyristor will conduct, either it may be thyristor, whatever the power semiconductor device that we are using, will conduct for a period of 120 degrees. And as we seen in the 180 degree mode of conduction, the load that we are considered is a star connector load. But here this 120 degree mode of conduction is most suitable for the delta connected load. Okay, so because the 6-step type of waveforms across any of its phase, that we will see, once we will go through the operation of the circuit. Okay, after that we will draw the waveforms. There you can see how we will get the 6-step waveform for this 120 degrees mode of conduction. Okay, so this means at any instant, okay, only two devices are conducting, because as you can see in the 180 degree mode of conduction, at every instant, because the instants we are divided into 60 degrees of interval, right? So for every 60 degrees of interval, there the three devices were turned on, like just now, in the previous class that we have seen. But here, for every instant, only two devices are conducting, because the device conduction period, here it is, we have considered 120 degrees. Okay, then of course here the phase voltages is equal to line voltages. So how it is means here the VAB is equal to V, VBC is equal to minus V by 2, and VCA is equal to minus V by 2. That we will see one by one. So in 120 degrees mode of conduction and in 180 degrees mode of conduction, the circuit is same. Okay, the circuit is same. Here, the same circuit we have considered for the 120 degree mode of conduction, because there are total 8 number of switches present in the 3-phase inverter. Okay, and each phase having 2 switches which are connected in series. And here the S1, S3, S5 are called as a positive group of switches, and S2, S4 and S6 are called as a negative group of thyristors, right? So why we are dividing positive group and negative group means there is a reason behind this. Okay, why? Because here the same concept that we are discussed in the 180 degree mode of conduction, which is here the phase difference between S1 and S2 is 180 degrees only here also, because if once S1 is conducting, after 180 degrees only S2 will start conducting. But here the only difference is in 180 degree mode of conduction, the S1 conduction period is 180 degrees, but here the every switch conduction period is 120 degrees only. So from 120 to 180 there is no conduction. Okay, and after 180 degrees only the S2 will start conducting. Okay, so here also the conduction difference between S1 and S2 is 180 only, but the only difference is the conduction period is 120 for every switch. And the second condition here is the phase difference between the positive group of conductors, which are S1, S3 and S5 is 120 degrees. Which means, suppose if S1 starts at 0 degree, then S3 will starts at 120 degrees, then S5 will starts at 240 degrees. Similarly, in the negative group of thyristors also, because S1, if S1 starts at 0 degrees, then S2 must be starts at the 180 degrees. So, if S2, S4 and S6, if S2 starts at 180 degrees, okay, then plus 120 degrees, after 180 plus 120 degrees, okay, so which is 300 degrees, S4 will start, and after plus 120, this is 420 degrees, at 420 degrees, S6 will turn. So now you can see here 0 and 180, okay, 120 and 300, the phase difference between 120 and 300 is again 180, and the phase difference between 420 and 240 is again 180. So which means the phase difference between the conduction difference between this is 180 degrees, okay, and this is 120 degrees, and this is also 120 degrees, and this is also 120 degrees, and this is also 120 degrees, but not between S3 and S6, because this is from the one S3 is positive group of thyristors and S6 is negative group of thyristors. So there is no relation between the positive group of thyristor and negative group of thyristor. But in the same leg, again there is a relation, right? So based on this relation, again we are going to draw the control circuit first. Then after that, from the control circuit, we will derive again the same procedure. Again we will derive the phase voltages, that is VAO, VBO and VCO, and from that we will draw the phase voltage waveform, and then after that, from that we will draw the line voltage waveform also. Right. First, we will go for the same way here, segment 1, segment 2, segment 3, which means this is phase A and this is phase B and this is phase C. In phase A, what are the switches are there? S1 and S2. And in phase 3, what is that? S3 and S4 and S5 and S6. These notation you can give anyway, because in the 3-phase converter, 180 degree mode of conduction, I have taken the different, representation, because here it is S1 and here it is S2 that I have considered. Okay. So that is not a problem, right? That's why I am considered in a different sequence, right? In the first case, first S1 is turned on. Okay. So how long the S1 should turn on? For 180 degrees. So here this is 0 to 60, 60 to 120. So S1 should turn on for 120 degrees, because here it is 120 degree conduction mode, right? So that's why S1 should turn on for 120 degrees. Then the phase S1, and then here in the second leg, what is there? S3 is there, and the phase difference between S1 and S3 is 120 degrees. So which means after 120 degrees, S3 should turn on. That's why here you can see after 120 degrees here, S3 is turned on. Then in the next leg, what is the switch? That is S5. Okay. And after 120 degrees, S5 is turned on. Okay. So which means first we have represented the positive group of thyristors, which is S1, S3 and S5. And S1 is connected in phase 1 and S3 is connected in phase 2 and S5 is connected in phase 3, which means phase A, phase B or phase C. Right. So that's why here the phase difference between the switches present in the positive group of thyristors is 120 degrees. So that's why first S1 is turned on, after S3, 120 degrees, S3 is turned on, after 120 degrees, S5 is turned on. Right? Okay. Then we will also indicate the other switches. In the first segment, which is phase A, what is the other switch that is connected? S2. Okay. And S2 should turn on after 180 degrees of S1 starts conducting. So S1 starts conducting at 0 degrees, then which means after that, after 180 degrees, S2 will start conducting. So which means in between 120 and 180, there is no switch is conducting. Okay, no switch is conducting in between 120 and 180 degrees. So again, how long the S2 will conduct? Again for 120 degrees, so which means 180 to 300, this is 120 degrees. And after 120, after S2, then when S1 will start, after 180 degrees, S1 will start. So which means 180 to 180, 360. So at 360 only S1 will start, but S2 will conduct up to 300 only. Again here 300 to 360, no thyristor or no switch will turn on. No switch will conduct, not turn on, no switch will conduct. And this thing will repeat continuously. Then coming to the second phase. And what is the other switch that is connected to the phase 2? Which is S4. Okay. So S4 is conducting. After 180 degrees, S4 will start conducting. S2 start at 120. So 120 plus 180 is 300. So that's why S4 starts at 300. But in between 250 and 300, again no switch is conducting. Then S4 starts conducting at 300. So after 360, after 180 degrees, which is 300 plus 180, again it is 420. Okay. So at 420 again S3 will starts conducting. But in between, what is that? What is that? 360 plus 60? It is 420. Okay. So from here, in during this period, again no thyristor will conduct. No thyristor will conduct, right? Similarly, in the phase C. In the phase C, first S6 will conduct, and what is the other switch that is in the present in the phase C is S5. Okay. Then here, after S6, it is starts conducting at 60, 60 plus 180, 240. So that's why at 240, the S5 will start conducting. So here, S6, and during this period, again, no switch is conducting. So like this here, for a duration of, in every phase, for a duration of 60 degrees, okay, which means once thyristor is conducting, after 60 degrees, no switch is conducting. Then after, another switch starts conducting. And after 60 degrees, okay, and duration of the 60 degrees, no switch is conducting. Like this here, it is repeating. The same way, what is the procedure that we have followed in a 180 degree mode of conduction? The same procedure here also we can apply. But the only difference is, there the switch was conducting for 180 degrees and here the switch is conducting for 120 degrees. That is the only difference between the 120 degree mode and 180 degree mode of conduction with respect to this control circuit. Right? Now, as you can see, during 0 to 60, what are the switches are conducting? Only 2, because in 180 degrees there are 3. This is also one of the advantage here, which is 1, 4, and here it is 1, 6, and here it is 3, 6, and here it is 2, 3, and here it is 2, 5, and here it is 4, 5. Again, the same thing will repeat: 1, 4, and 1, 6, and 3, 6, 2, 3, and 2, 5. The same it will repeat. Okay, so we have to make sure up to 360 degrees, and after 360 it will repeat again anyway. Right? Now we are going to first in the step 1, what are the two switches are conducting? 1 and 4. That's why here, as you can see, 1 is in the positive group, okay, and 4 is in the negative group. So as you can see, in each case, in each interval, one thyristor from the positive group of thyristors and one thyristor from the negative group of thyristors will start conducting. Okay, so that's why here you can see. Then if you redraw the equivalent circuit for this one, then you will get, because here the switch 1 is connected to phase A. Okay, this is the upper switch, and for phase B is connected to switch 4. This is the lower switch, and in between the 0 is there, the neutral point. So that's why here it is 0. Okay, so VAO and VBO. That's why here VAO positive, negative, and here also it is positive, negative. But actually our voltage is positive, negative. Okay, so that's why here it will divide VAO, which is equal to Vs by 2, but VBO, which is equal to minus Vs by 2. VAO is Vs by 2, VBO is minus Vs by 2. And VCO, the phase C, the two switches are in the off position, so that's why VCO is equal to 0. VCO is equal to 0. Right? Then here, in the next step, from the again same from the control circuit, what are the two thyristors are conducting? 1 and 6. See here, 1 and 6. So in 1 and 6, the 1 is connected to phase A and 6 is connected to phase C, and the 1 is connected to the upper switch and phase C is connected to the lower switch. So that's why here VAO and VCO. So which means again here VAO is equal to Vs by 2 and VBO, which is equal to, of course for phase B there is no switches turning on, so that's why VBO is equal to 0 and VCO, which is equal to minus Vs by 2. Minus Vs by 2. Similarly, in the step 3, 3 and 6 are turned on. Okay, and 3, and here it is the 6. So 3 is connected to phase B and 6 is connected to phase C, and the switches connected to the phase A are still turned off, both the switches. So that's why here it is in between VBO and VCO. So that's why here VAO, which is equal to 0, because the switches which are connected to the phase A are both are turned off. So that's why VAO is equal to 0, and VBO, which is equal to Vs by 2, and VCO, which is equal to minus Vs by 2. Okay, minus Vs by 2. So here, similarly, we can follow step, suppose let us consider here step 4, 2 and 3. Okay, so 2 and 3 are connected to 2 and 3. Okay, VA, okay, which means here VAO is equal to minus Vs by 2 and VBO, which is equal to positive VBO, which is because 1 and 3, right? Okay, so which is connected to positive, so Vs by 2 and VCO is equal to 0. So from this circuit itself, we can able to write the VAO, VBO and VCO equations. Then now we know the phase voltages equation at every instant. Every instant means this is the first instant and this is the second instant and third instant and fourth, fifth and sixth instant, like this, right? So now we are going to draw the phase voltage waveforms, VAO and VBO and VCO. So during this, 1 and 4 are turned on. 1 and 4 are turned on. So because now here I am just drawing for our reference purpose. Okay, the phase here 1 and the switches here, this is S1 and S2. Okay, so similarly 3, 4 and 5, 6. Okay, and 3, 4 and 5, 6, right? Okay, so here this is phase A and this is phase B and this is phase C. The loads are connected like this way. Now 1 and 4. Okay, 1 and 4. So 1 is connected to positive group, so VAO is equal to plus V by 2. So that's why here VAO is equal to plus V by 2. And 4 is connected to negative group, so that's why VBO is equal to minus Vs by 2 and VBO is equal to here minus Vs by 2. And VCO is equal to 0 because no switch connected to the C phase is turned on, so that's why VCO is equal to 0. Right. Then next, here 1, 6 are turning on, 1, 6 are conducting. So, and 1 is again the positive group which is connected to A phase, so which means VAO is equal to plus Vs by 2. So that's why here still it is plus Vs by 2. And VBO 6 is associated with the C, but there is no switch is conducting associated with phase B, so that's why here it is 0. Then next, what is that? 6 is connected to phase C and that is connected in the negative group, so that's why here minus Vs by 2. Here it is minus Vs by 2. And next, in between, in the third, what is that instant, here 3 and 6. Okay, and 3 is connected to phase B and what is that? 6 is connected to phase C. And for phase A, there is no switch is conducting. So that's why here phase A is equal to 0, VAO is equal to 0. And VBO, which is 3, so this is positive group, so that's why VBO is equal to plus Vs by 2. And here 6 VCO, which is negative group, so that's why here VCO is equal to minus Vs by 2. And next, here 2 comma 3. So 2 is for phase A and 3 is phase B. So phase C is 0 here, right? So phase A 2 means here negative group, so that's why here minus Vs by 2. And 3 is positive group, that's why here plus Vs by 2. And C is 0, so here 0. Then in between 240 to 300, 2 comma 5. So again 2 is associated with the negative group, so that's why here it is minus Vs by 2. And VBO, there is no switch is conducting, that is connected to the phase B, 0. And VCO is again plus Vs by 2 because it is switch 5 is connected to the positive group of thyristors. And similarly here 4 comma 5, so 4 is connected to B and 5 is connected to C. So here VAO is equal to 0, the no switch connected to phase A, and VBO is equal to negative group, so minus Vs by 2, and here positive is positive group, so plus Vs by 2. So up to 360 degrees we have drawn, up to 360 degrees. The same circuit will repeat after 360 degrees also, because as you can see, every switch or every phase is conducting for 180 degrees with the same voltage. So 120 degrees. And here also you can see 120. And here also you can see 120. The plus Vs by 2 and minus Vs by 2. Which means first for 120 degrees the output voltage is Vs by 2. And next for the 60 degrees it is 0. And next for the 60 degrees it is minus Vs by 2. And next for the 60 degrees it is 0. Similarly for the phase B also, first of course starts from here. Okay, first 60 degrees it is 0, then 120 degrees positive, and next 60 degrees 0, and next 120 degrees is negative. Similarly VCO also here, as you can see here, first 60 degrees is 0, and the next 120 is negative, and next 60 is 0, and next 120 is positive. Okay, so here the 3-phase inverter output voltage is a stepped waveform, as you can see in the 120 degree mode of operation as well as in the 180 degree mode of operation. The output voltage is stepped waveform. Okay, in 120 degrees mode of as well as in the 180 degree mode of operation, the output voltage is a stepped waveform. But as you know, the function of the and after that we will also discuss the line voltages. Okay, so same way here VAB, which is equal to VA minus VB, or VAO minus VBO. So what is VAO here? VAO is equal to plus Vs by 2, and VBO is equal to minus Vs by 2, right? No. VBO is equal to VAO is equal to 1 comma 4. Okay, 1 comma 4, yeah, plus Vs by 2 and minus Vs by 2, right? So that's why here Vs by 2 minus of minus Vs by 2, so which is equal to 2 Vs by 2, which is equal to Vs. That's why here you can see during first 60 degrees, here it is Vs. Similarly VBC is equal to VBO minus VCO. Okay, so from this VBO is minus Vs by 2 and VCO is also minus Vs by 2. Okay, VBO is minus Vs by 2 and VCO is also minus Vs by 2. No. VBO is 0 and VBO is 0. Yeah, here VBO is 0 and VCO is minus Vs by 2. So that's why here 0 minus of minus Vs by 2, which is equal to plus Vs by 2. So that's why here, here during this period, here it is plus Vs by 2. Okay. So similar way here, that is Vs by 2 and 0 and 0 and Vs by 2. Okay, so that's why here, of course, during the same time here we are getting what is that, Vb minus Vc. Vb is 0 and Vc is what is that, minus Vs by 2, Vc, Vbc. Yes. So similarly Vca. Okay. The same way here, the Vab we can draw for up to 360 degrees. This is how up to 360 degrees. And similarly Vbc is also up to 360 degrees. But as you can see here, the difference between the line voltages and phase voltages. Here the line voltages is a single step waveform. Okay, stepped waveform. And here the phase voltages are the stepped waveform. And here the line voltages are also the stepped waveform. Okay. But here the phase voltages are single step voltage waveform because 0 and Vs by 2. Only 2 steps are there. Okay. But here 3 steps are there. One is Vs, Vs by 2 and 0. Okay, or the minus Vs by 2. Okay. So like here, there are 2 step waveform is there. Okay. That's why here the phase voltage waveform and the line voltage waveform both are different. Then you may get a doubt like, actually the function of the inverter is, it is DC to AC. Right. So AC is a pure sine wave, but we are not getting the sine wave. Okay, we are getting a square wave. Okay, or a stepped wave. But as you can see here, this is resembles like sine wave. Right? Okay. Same way here also. So when you increase the number of levels, okay, then the output voltage waveform is more nearer to the sine wave. Then how we can get this? By going for, because this is usually a 2-level inverter, whatever the inverters that we are discussing, because the 2 levels only we are getting. Okay, one is what is that, either Vs or Vs by 2 and 0, and not even 0 here, directly from Vs by 2 to minus Vs by 2. Okay, so there are only 2 levels or 2 levels mostly. So but there are 5 level and 7 level, 9 level, 11 level inverters are there. Okay, so when you go for the high level of inverters, then you will get more nearer to the sine wave, or otherwise we can use some filters at the output side, and that filters will eliminate whatever the harmonic content present in the output voltage. Okay, then we will get the pure sine wave. As you can see here suppose if you go for the high levels is nothing but here, let me start from, maybe let us consider here it is starting from the 0. Okay, so like this you will get. Okay, now even one level is extra came here. Okay, now this one. So first 0 and 1 and 2 and 3 and 4. Okay, the same way here also 1, 2, 3, 4 and 0. Okay, so here 1, 2, 3. 1, 2, 3, 4. No, this is also wrong. So here it is 1, 2, 3. We will go for only 3. And again 1, 2. This is 1 and this is 2 and then 3. Right. So which means here the more nearer to the sine wave, this one, when compared to this. Right. If you go for more high levels, okay, so here now we just write 3, then we will go for some more levels. But usually we don't have like 4 level and 6 level and 8 level inverter. Okay, only odd number of level of inverters are there. So 1, 2, 3, 4, 5. Again 1, Here we will get another level, and here we should get another level, and here we should get another level, right? So like this. So here more nearer to the sine wave when compared to this one. Okay, so that is how we will go for the high levels of multi-level. I mean, if you want to get the sine wave, we will go for the high level of course, there are different ways to get the pure sine wave. Okay, either we use the filters or we will go for the multi-level inverters. This is about the 120-degree mode of conduction. So here, once if you understood the 180-degree mode of conduction, then it is very easy to understand the 120-degree mode of conduction. Only the difference between these 120 and 180-degree mode is there that switch is conducting for the 180 degrees, and here the conductor switch is, every switch will conduct for 120 degrees. That is the only difference between 180-degree mode and 120-degree mode. Otherwise, as you can see, the procedure is same. And the difference between 120 and 180-degree mode, as you can see, in 180-degree mode of conduction, there are 3 switches are conducting at every every instant means at 60 degrees of interval, for every 60 degrees of interval. But here only 2 switches are conducting. So that is also another difference between 120 and 180-degree mode of conduction. Thank you. We will discuss next topic in the next class.
Like, share and subscribe. Hit the bell icon for more updates.